Hi, and welcome to the CFU video for Unit 5, Day 7, Part 2b. So at this point, you should have tried the CFU on your own on a separate piece of paper. You're balancing this combustion reaction. If you haven't, go ahead and pause this video now, and when you press play again, I will show you how this is done. All right, so they're asking me to write the balance equation for the combustion of C4H10. So our first step is always the same, to write the unbalanced equation using our organic molecule, C4H10, and O2 as our reactant, so what we start with. And for our products, we're going to have CO2 and H2O. Again, the order of CO2 and H2O doesn't matter. The order of these things don't matter as well. As long as you have them written down, doesn't matter what order that you write them in. Okay, so now that we have that done, the next thing we're going to do is figure out how many atoms we have on both sides so we know what our coefficients need to be in order to balance them. So on the reactant side, I have 4 carbons, I have 10 hydrogens, and I have 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and for oxygens, I have 1, 2, 3. Now, the next thing I want to do is I want to start balancing by changing the coefficients, and I'm going to do oxygen last, of course. So remember, that's one of our key strategies. So starting with carbon, I have 4 on this side. I want there to be 4 on that side. So I'm going to change the coefficient in front of CO2 to be 4. Now remember, CO2 is a compound. So in addition to carbon, by changing that coefficient, I also change the number of oxygens on the product side. So I have 4 times 2, which is 8, plus the 1 from water. I have a total of 9 oxygens now. Now I'm going to change the, now I'm going to try and balance my hydrogen. So I have 10 on the reactant side and 2 on the product side. So the coefficient that must go in front of water, H2O, is a 5, because 5 times 2 will give me 10, and I want 10 on both sides. So once I have my hydrogens balanced, don't forget I need to change the tally for my oxygens, because water has oxygen in it as well. So I have 5 from water plus the 8 from CO2. That gives me a total of 13 oxygens on the product side. All right, my last step is to balance the number of oxygens that are on the on both sides of the equation. I have 2 on the reactant and 13 on the product side. So I'm trying to figure out, well, what number could I multiply 2 by to get me 13, right? Well, there's no whole number you can multiply 2 by to get 13. However, there is a decimal that you can multiply 2 by to get 13, and that decimal is 6.5. So I'm just putting that in there as a placeholder, because remember, we can't keep this as a decimal. But to get rid of the decimal, we just multiply all the coefficients by 2, right? Because that will get rid of that decimal here, and whatever you do to one side, you have to do to both sides. So we're going to multiply the 1, the invisible 1 in front of C4H10 by 2. So that gets multiplied by 2. The 4 in front of CO2 gets multiplied by 2. And the coefficient in front of H2O gets multiplied by 2 as well. And now we have our new coefficients, 2, 13, 8, and 10. So when I write this balance equation out, I get C4H10 plus 13O2 goes to form 8CO2 plus 10H2O. And it's never a bad idea to just check one last time to make sure it's balanced. So to check that, I'm going to just do a tally again for carbon, hydrogen, and oxygen. So starting with my carbons, I have 2 times 4, I have 8 carbons on the reactant side. For hydrogens, I have 2 times 10, I have 20. And for oxygens, I have 13 times 2, which is 26. On the product side, I do the same thing. So for carbon, I have 8 times 2, which is, 8 times 1, which is 8. I have 8 carbons. For hydrogen, I have 10 times 2, which is 20. And for oxygen, I have 8 times 2, which is 16 from the CO2, plus 10 from the water. So 16 plus 10 will give me 26 oxygens. And that is a happy, balanced equation. All right, so you have an extra ticket to take in your Schoology folder. That's it for this video. Have a quality day.